This standard is about graphing absolute value. We're usually going to do this with a table of values, so I'll start by making one of those. I'm going to pick some numbers. I'll talk more about why I picked these specific numbers in a future example. So you may recall the absolute value is the distance a number is from 0. So I'm going to take the absolute value of each one of these numbers in the x column, and the answer to that will be y. So -2, I'm going to put it in place of x in this equation. That means I'm taking its absolute value. And the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So let's graph these. So if x is -2 and y is +2, I'm over here. X is -1, y is +1 is there. 0, 0 is the origin right there. 1, 1 is there, and 1, 2 is there. If you graph these, you'll get a V. Absolute value equations always come out in the shape of a V. And a special point on this graph is the point of the V. This is called the vertex. The coordinates of the vertex in this example were 0, 0. And you can see that's the number in the middle of the table. And that's one of the reasons I picked these numbers. I always want the vertex to be the middle number in the table to make sure I get both sides of the V in my table of values. So here's a slightly more complicated example. So I need to think about what number is going to be the x-coordinate of the vertex, and that's going to be the number I put in the middle of my table of values. The way you get that is you need to find a number that's going to make what's inside the absolute value equal to 0. So somehow I want to make x minus 2 equal 0. And the way I'm going to do that, I'll just write an equation. X minus 2 equals 0. What value for x makes that 0? The value that's going to work there is 2. So 2 is going to be the number I put in the middle of my table. And then I'll pick 2 bigger, and I'll pick 2 numbers that are smaller. So now we'll go ahead and do the math. I'm going to replace x with 0 in this equation. So I have 0 minus 2, which is -2, and then I need to find the absolute value of -2, which is 2. When I put 1 in that equation, I get the absolute value of 1 minus 2. One minus 2 is -1. The absolute value of -1 is 1. When I put 2 in the equation, I get 2 minus 2, which is 0. The absolute value of 0 is 0. When I put 3 in, 3 minus 2 is 1. The absolute value of 1 is 1. 4 minus 2 is 2. The absolute value of 2 is 2. You can see the y values look a lot like the last example, but the x's are different, so that means the equation has moved a little bit. So 0 is at 2. I'll put it down there. 1 is up at 1. 2 is at 0. 3 goes back up to 1. And 4 is at 2. I connect those, I have another V. Except this time the vertex is at 2, 0. So it's like the whole graph moved over 2 units to the right. And you can graph these equations by thinking about moving the vertex around. But we're mostly going to keep going with the table of values. This example is going to have more complicated arithmetic than the last two, but it's basically the same idea. First, I have to figure out what value for x is going to make what's inside the absolute value equal to 0. So x plus 1 equals 0. I can just think about that, or I could go ahead and do out the arithmetic if I wanted. And I see that x equals -1 is going to be what goes in the middle of the table. So here's my table. I have negative 1 in the middle. I need two numbers bigger, that's 0 and 1, and two numbers smaller is negative 2 and negative 3. So I'm going to do all the arithmetic out over here on the right side of the slide. So I'm going to have negative 2 times the absolute value of negative 3 plus 1 minus 3. So the absolute, or let's start with what's inside the absolute value. Negative 3 plus 1 is negative 2, and the absolute value of negative 2 is 2. So this equals negative 2 times 2 minus 3. Negative 2 times 2 is negative 4 minus 3. So that's negative 7. If I put negative 2 in the equation, I have negative 2 times the absolute value of negative 2 plus 1 minus 3. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. So this equals negative 2 times 1 minus 3, which is negative 2 minus 3, which is negative 5. If I put negative 1 inside of the absolute value, I'm going to have negative 2 times negative 1 plus 1 minus 3, which is 2 times 0 minus 3, or negative 3. Next I'll put 0 in. So I'm going to have negative 2 times the absolute value of 0 plus 1 minus 3. 0 plus 1 is 1. Absolute value of 1 is 1. So this is negative 2 times 1 minus 3, which is negative 2 minus 3, which is negative 5. And I'm running out of slide here, so I'm going to use the symmetry I see here. I think this last point is negative 7. So let's graph those. Negative 3 goes with negative 7. 3, 1, 2, 3, 4, 5, 6, 7. Let's move up. Negative 2 goes with negative 5. Negative 2, 1, 2, 3, 4, 5. Negative 1 goes with negative 3. 0 is back down to negative 5, and 1 is negative 7. So the graph of this equation looks like this. And the vertex is at negative 1, negative 3.